November 1572. A Danish astronomer walking home. Tycho Brahe, 26 years old, he looks up and freezes. There, directly above his head, in the constellation Cassiopeia, a star that didn't exist yesterday. Bright as Jupiter, no brighter, so bright you could see it during the day. Tycho doubts his own eyes. He asks others to look. They see it too, the new star. The Stella Nova. What Tycho didn't know, he wasn't observing the birth of a star. He was observing its death. Let me tell you what this moment meant. For 2,000 years, the world believed in a truth that Aristotle had formulated. The heavens were unchangeable, eternal, perfect. Only on Earth, in the corrupt mortal world beneath the moon, did changes occur. The stars, they were forever, and then came this star. Tycho measured night after night with perspective. Precise instruments he had built himself. He proved this star was not in the atmosphere, not a comet's appearance. It was out there among the fixed stars in the unchangeable heavens. The heavens had changed. For 16 months the star shone, slowly fading. In March 1574, it disappeared. All that remained was a question. What was that? Today we know 13,000 light years away, a thermonuclear explosion, a white dwarf, the dead core of a star, exploded, a type Ia supernova, the energy, as much as our sun radiates in 10 billion years. In a single moment. For 453 years we studied this remnant, the Tycho supernova remnant, we thought. We understood it, we were wrong. Have you ever seen a new star in the sky? Write it in the comments. 2025, 43 years after Tycho's observation, a scientist named Noam Soker analyzes new images. High-resolution data, pictures from telescopes Tycho couldn't even dream of. And there, he sees something. Two protrusions on either side of the main shell like ears, small details. Easy to overlook, but Soker recognizes something. These ears, he's seen them before. In 3 other supernovae, Kepler, SNRG 299-2.9, SNRG 1.9 plus 0.3, all the same type. Type Ia, and all with the same secret. What these ears mean, science only understood in recent years. They are the signature of something forgotten, something that should be there but shouldn't be possible, a planetary nebula. Let me explain this. When a star dies, a star like our sun, it swells up, becomes a red giant, casts off its outer layers, this shell of gas and dust. That's a planetary nebula, one of the most beautiful sights in the universe. But these nebulae, they fade away. 200,000 years. They dissolve, disappear into interstellar space. Theory said when a white dwarf explodes, this happens millions of years later, long after the nebula has vanished. In empty space, the ears tell a different story. They show the white dwarf didn't explode in empty space. It exploded inside the nebula. While the nebula still existed, a supernova inside a planetary nebula. Scientists call it SNIP, Supernova Inside a Planetary Nebula. But here's the puzzle. How can this be? A white dwarf needs time to explode. Millions of years we thought the nebula only exists. For 100,000 years, something doesn't add up. Do you believe there are more hidden secrets in space? Like this video if you do. Here's what the new analysis reveals. Imagine 2 stars, a binary system. One of the stars becomes a red giant, swells up, casts off its shells. The planetary nebula. What remains is the core, a white dwarf, but the second star is still there, also a white dwarf, and the two come closer together. They begin to merge, not through accretion, not through slowly collecting material, but through direct collision. Core-degenerate scenario. The white dwarf plunges into the outer layers of the giant star, spirals inward, merges with the core, and then delay, not millions of years, not even 1,000 years, weeks, maybe years, maybe tens of thousands, just enough time that the nebula still exists. Imagine the merged cores reach critical mass, critical density, temperature rises, 1.4. Solar masses compress to the size of Earth. The carbon fire begins, a thermonuclear chain. Reaction: the star explodes, but this time not in empty space, this time inside the nebula. The shock wave races outward, strikes the nebula wall, shapes them, deforms them, creates. The ears: do you understand what this means? We studied Tycho's supernova. We thought we knew how it died, but the truth was hidden. In small details, in structures we can only now recognize. And here is the larger realization. If Tycho was a SNIP, if Kepler was a SNIP, if these three others were also SNIPes, how many more are there? The preliminary estimate, 70–90%. Of all type 1, a supernovae might be SNIPes, 70 to 90%, almost all of them. That means how white dwarfs explode when they explode, where they explode was possibly wrong. Not completely wrong, but incomplete. The supernova that Tycho Brahe saw that helped him overthrow. The old world view is overthrowing a worldview again. Our own. What do you think? What other cosmic secrets have we overlooked? Comment your theory. On November 11, 1572, a young astronomer looked at the sky and saw a star that would change the world. Today, 453 years later, this star is still changing the world, not through its appearance, but through what it had hidden all along. Sometimes the greatest discoveries are not the new things we find, but the old things we finally understand. Did you like this story? Subscribe for more hidden secrets of the universe, and tell me which historical discovery should I investigate next.